Hello, good day. So, welcome to my channel. Again, this is Ernesto C. Prudenciado Jr. And let's continue our discussion in mechanics. So, we are now in parabolic cables. So, definition of parabolic cables. If a flexible wire cable is suspended over two supports and where most of the loads are distributed horizontally, as in a suspension bridge, the cable assumes the shape of a parabolic segment. Okay, so most of the time, parabolic cables are related to bridges, no? Wherein we have this weight horizontally. So this is the bridge deck, and it is suspended, no, through a cable, a main cable that is assumed to be in a parabolic equation. Okay, so by the way, no, we have another type of cables that is or that are catenary and cables subjected to a concentrated load. So we will discuss that later on. So as of now, we are going to focus on parabolic cables. Okay, so if I will cut a segment through the cables, so I can have this figure. Uh, we have this figure. So H here is the horizontal tension, and T here is the tension within the cable, no? So arbitrary point, no, in the cable. So let's assume this segment. So if we have the horizontal distance of x, okay, so the weight of the cable or the weight that is suspended of the cable, so this is W in terms of Newton per meter because this is horizontal. So uh, let's summarize this as big W, okay? And if I'm going to draw the free body diagram of this segment, so I have here a triangle. So this is the big W, this is the T, and this is the horizontal H, and this is the theta. Okay, so we can now have equation here that the tension along the cable is T squared equals W squared plus H squared. Okay, so this is our equation 1. Or I can rewrite this as T is equals to square root of W squared plus H squared. Okay, so this is our equation 1. Now, looking back to the segment that I already drawn, so summation of moments about A equals to 0. So I will sum up the moment here, A. So what are the forces involved? H times Y, the segment or the sag of the segment, equals to the W times X, okay, because W is in uniform load, so we have to compute the overall load in terms of this segment. So Wx times the moment arm x over 2. Okay? So this is the forces involved, no? The moments involved in our segment. Now, we can summarize this as W x squared over 2. Okay? So take note of this equation. Okay, if I may relate this equation to our original figure in our LP here. Okay, so the overall bridge, no, this one. So this is going to be Y will be replaced by D because D is the overall sag of the bridge, and W where X is equals to L over 2. Okay, half of the bridge length or half of the horizontal bridge length. So this is going to be squared over 2. What will happen to the equation? This becomes W L squared over 4 times 2. So this is going to be H WL squared over 8D. Okay, so this is our equation 2. Remember this. equation 1 and equation 2. Okay? So another thing to memorize is the length of the cable. But we have two formulas for the length of the cable. That is the approximate and the exact. So write the formula for the exact first. So exact S is equals to L squared over 8D times M K plus Ln M plus K, where M is equals to 4D over L and K is equals to square root of 1 plus M. Okay, so I will not going to derive this equation, but this is from integral calculus to find the length of a parabolic line or parabolic curve. So if you want to verify this formula, you can recall your integral calculus. Okay, so there is also approximate length of the cable S. Approximate is equals to L plus 8D squared over L minus 32 D to the fourth over 5L cubed. Okay, so if you want to ask if where this formula came from, it is from binomial theorem. Okay, so the derivation is quite long, so I will not do it here. So these are the four formulas that you have to derive. Okay, so this one, this one, this one, and this one. Okay, so you have to memorize that for you to solve parabolic cables problem. Okay, so we have here an example. So this is taken from our LP. So example problem number 6. A cable is stretched between two supports at the same level, has a span of 80 and a sag of 10 meters. The tension of the lowest point of the cable is 20 kilonewton. If the cable supports a uniform load along the horizontal, so this is the hint, no, that this is a parabolic cable. If you are going to take the board exam, so sometimes the problems has no figure, but to determine that, there is a hint, no, for particular for this example, the hint is the cable supports a uniform load along the horizontal. So this means a parabolic cable. Okay, so question is find the tension in the cable in the supports and the length of the cable. Okay, so let's solve this. So what are the givens? Sag equals to 10 meters. So this is also called as D. What else? So the cable is 80 meters. So the L is 80 meters. And the tension in the bottom or the lowest point of the cable, so horizontal yan, H is equals to 20 kilonewton. Okay? So that is the given. Let's solve. So the first question is the tension of the cable in the supports. So since this is symmetrical, so whatever is the tension of A, so whatever the tension of A is equals to the tension of B because this is symmetrical. Okay. So let's solve. What we have is the formula of T squared is equals to square root of W squared plus H squared. H is known, but we don't have W or the weight of the horizontal load of the cable shown. So T is what we are going to solve. So let's have a W. So the weight is equals to the uniformly distributed times L over 2. So the weight considered, no, in our force polygon is the half of the weight of the overall uniform distributed load. So that's why this is L over 2. Okay? So, yes, we have L, 80, but we don't have the distributed load, small w. So let's see if we can find small w from this equation. So recalling equation number 2, so H is equals to W L squared over 8D. Okay? Okay, we can solve this because we have H, we have D, the sag, and we have L. So we can find W. So W is equals to, let me substitute first, 20, this is kilonewton, equals small w times L is 80 squared over 8, D is 10, no? So I can find W is equals to, so so the answer is 0.25. This is kilonewton per meter. Okay? So we can now solve for the big W because we have now the small w. So W is 0.25. So from this formula, times 80 over 2. Okay? So big W is equals to times 80 divided 2. So that is 10. So the unit is kilonewton. It's already a weight. So substituting this to our formula or equation number 1. So again, equation number 1, we'll write T equals square root of W squared plus H squared, no, from force polygon that I derived a while ago. So T, we have now the components W and H. Square root of W is 10 squared plus H is 20 squared. So we can solve T. What is T? So square root of 10 squared plus 20 squared equals 22.36 kilonewton. So this is the tension in the support, no? A and B. Okay, either, no? Because it is symmetrical. So whatever is the tension in A, that will be equals to the tension in B. So, okay. So next is the length of the cable. So we have to solve the approximate and the exact. Okay, so let's solve first the approximate. S is equals to, I will call this as SA. So the formula is L plus 8D squared over L minus 32 e to the fourth over 5L cubed. Okay, we have L, D, what else? So, okay, so may nakita. So let's substitute this. L is 80 plus 8 times D is 10 squared over L minus 32 D is 10 to the fourth over 5 times 80 cube. Okay, this is 80. So what is the answer? So 80 plus 8 times 10 squared over 80 minus 32 times 10 to the fourth divide 5 divide 32, 80 cube. the answer is 89.88 meters. Okay, so let's try to solve for the exact. So like I will call this as SE as S exact. Okay, so the formula is quite long, no? L squared over 8D MK plus ln m plus k. Okay, so where m is equals to 4d over l and k equals to square root of 1 plus m squared. Okay, so what we are going to solve first is the m. We have here, so m is equals to 4 times d is the sag, no? 10, that is given over 80. So this is what? 40 over 80. So this is 1 half or 0.5. K is square root of 1 plus 0.5 squared. So what is that? 1 plus 0.5 squared square root. So 1.118. 1.118. Okay, so we can now substitute to our general equation for the exact. So SE equals 80 squared over 8 times 10, quantity M is 0.5, K is 1.118, plus ln M is 0.5, K is 1.118. Okay, so answer is so I will just store this, shift store A, so 80 squared over 80 times 0.5 multiplied by alpha A plus ln 0.5 plus alpha A. So what is the answer? So the answer is 83.22 meters. So there is a difference, no, between the exact and the approximate. So around 6 meters. Okay, approximately 6 meters. So if the question in the board exam is find the exact and the approximate length of the cable, so you have to solve both. Or the problem in the board exam will ask you about the exact length of the cable only. So you have to memorize this formula for you to solve this. Okay. Okay, let's go to example problem number 7. The parabolic cable shown carries a uniform horizontal load of 20 kilonewton per meter. So if you can see in the figure, we have here an unsymmetrical but parabolic cable. So question is compute the value of A. Number 2 is compute the tension of the cable at A, so at the support A. And number 3 is compute the tension of the cable at the support C. Okay, so let's solve this. Okay, so solution. Okay, so I will draw the segment because this is symmetrical. I will draw the segment of this portion A here and this portion of B. Okay, so Okay, so let's solve. This is point A and point B. So I just divide the lowest point, two segments. Remember our formula. P equals square root of W squared plus H squared. Okay. And H is equals to small w L squared over 8D. Okay. So thinking of using these formulas, yes, this can be used, but this formula can't be used because this is derived from symmetrical parabolic cable. So we have here now an unsymmetrical parabolic cable. So in solving this, we have to go back to our principle. Okay? How to solve this? Okay. So let's not use this formula, huh? Okay? Let's not use this formula. I will erase this one. Okay. So summation of moments about A equals to 0. So what are the forces involved? So you have here a force W. Okay. So also here you have a force W2. Let's call this W2 and this is W1. W1, W2. Okay. So summation of moments about A. What are the forces involved? So tension at B, counterclockwise, moment arm. So the moment arm here is what? 12. Okay, 12. Okay, equals to W1 times moment arm is A over 2. Okay. By the way, the horizontal distance of this is A. And this is because overall length of the cable is 30. So this is 30A. Okay. So that is the equivalent of B. Wait. $30 minus A. Okay, so that is the equivalent horizontal distance of B, 30 minus A. Okay, so this is, so TB times 12, but W1, I can express that into small w times A times its moment arm A over 2. Okay, and okay, TB times 12 and W1 I can express that into small w times the horizontal distance A times its moment arm A over 2. So this becomes TB equals WA squared over 12 times 2, this becomes 24. But W is given here, it's 20. So TB equals 20A squared over 24. So what is this? Twenty divided by 24. So wait, 0.83. 0.833 A squared. So this will be our equation 1. Okay. In this figure at the right, so the segment at the right, we have also TB times the moment arm 6. Now because we have 6 here, this one. So equals to the horizontal also, which is W2 times its moment arm, or the B is equals to 30 minus A over 2. Okay. So but what is W2? We can express also W2 in terms of small w, yes, times B, which is 30 minus A, times its moment arm 30 minus A over 2. Okay? So what is TB? By the way, let's substitute first. The W is 20. 30 minus A squared over 2. So TB is equals to 20, 30 minus A squared over 12. Okay? So TB is equals to 20 divided 12. So we have 1.667 30 minus A squared. So this is our equation 2. Okay? So equating equation 1 and 2, okay? So what is our equation 1? Again, this is 0.833 A squared equals 1.667 30 minus A squared. So we can solve for A. Okay, let's solve. 0.833 alpha x squared equals 1.667 times 30 minus alpha x, okay, squared. Shift solve. Let's put 15. So the answer is 17.57. Okay. So A equals 58 meters. So this is the answer for question number 1. Okay. So we'll compute the value of A. Okay. So it's very easy, no? So all you have to do is to recall your algebra. For question number 2, compute the tension of the cable at A. So the tension at cable at A, okay, we have to use this. TA equals to square root of W1 squared plus H squared. Okay, so what is W1? So this is small w times A. Okay, so we know the value of A already. So this is W1. This is given, no? This is 20 times 17.58. Okay, so what is W? 20 times 17.58. Okay. Okay, the answer is 351.6 kilonewton. By the way, class, this H is just equal to TB. Okay? The horizontal distance, this one. This one. This is also H, no? So let's solve for first the TB because we have equation for TB, equation 1. 0.833 times A squared. So what is this? So 0.833 times 17.58 squared. Okay. 257.44 kilonewton. Okay. So we can now solve for TA. So this equation, W1. So what is W1? 351.6 squared plus H or TB equals 257.44 squared. So TA equals, so this is squared plus 351.6 squared square root answer. So the answer is 435.70 78 kilonewton. Okay? So this is the answer for letter or number 2. So there is a slight difference compared to our LP, but that is due to rounding off. Okay? The question number 3 is compute the tension of the cable at C. So at the support here. Okay? So let's solve. So solving TC. Okay? So again, the formula is TC equals square root of W2 squared plus H squared. Okay? But I will replace H as TB. TB squared. Okay? So we have now this formula. We have TV. We know already that. But W, we will solve W2 first before we can get our tension at C. Okay? So W2 is the weight of the horizontal uniformly distributed at the right segment. So that is 20 times B. But B is 30 minus A. Okay? So that is 20, 30 minus 17.58. So the result is 30 minus 17.58 times 20. So 248.4 kilonewton. So if we check this, this is supposed to be smaller than segment at the left because the cable here is shorter compared to the left segment. Okay, so the left segment is 351 and the right segment is 248.4. Okay, so this is correct. Okay, so we can now solve for TC. TC equals to square root of W2 is 248.4 squared plus TB is 257 point what 44 squared. Okay, so we can solve for TC equals square root of 248 squared answer plus 257.44 squared square root answer. So 357.74 kilonewton. Okay? So this is the answer for number 3. Okay? So there is just a small difference between the answer of our LP. So because this is due to rounding off. Okay.